sound loud, right, to all of you?
Yes, sir.
Yes, sir, it's clear.
Okay. So, share my screen. So, how was the quiz? I don't know. Anyone can unmute yourself and tell how was the quiz? You can tell your experience.
Sir, it was good.
It was good, sir.
Okay. Hope my screen is visible to all of you.
Yes, sir.
Yes, sir.
Okay, so I think we should to wait, or if anyone have doubt, please let me know, or what I can do, like I can do a summary session for week 5, revising the
Yes,
concept.
sir. Yes, sir. Please do the summary session.
Yes,
Because
sir.
that, so because what we hear that actually we can keep it in our mind. It will retain in the mind. That's why.
Yeah, so that's one thing, because I'm looking very less participant today. I don't know what is the effect, like because of which, or because of which one have done. Why this is a very less participant, only 26 till now, and it is 8-4 prox. It's because of which is that?
I think maybe they are relaxing for some time.
Or maybe, sir, they will join late.
Okay, yeah, maybe.
Maybe in another 10 minutes they will join, but I think we should start.
Yeah, we'll start the session. So anyone have doubt, please let me know. If anyone is waiting to just clear your doubt, we can discuss the doubt and then start the summary. Otherwise, from now itself, I will start the summary.
Sir, I think we should start the summary, and like whenever you proceed accordingly, we should ask the doubt so that everything will be covered in sequence.
Okay.
Yes, sir. We will ask doubt in between in the summary.
Okay. Okay, fine. So let me go with the lecture. Lecture wise, then I will get some idea. Then we'll do that. This is week 5. So week 5 graded is already extended till 3, and okay. Okay, so first of all, what is one-to-one function and definition and test? The first lecture is on one-one function. When we call a function is one-one, definition and test. So there are 2 tests. So first of all, you know that what is a function? Function is nothing but a relation which have 2 specific property. First thing is, suppose this is, if you are assuming this is a function, so there should be, and suppose this is a set as you are thinking for domain, and this is for codomain. So there should be no element remain when you are taking the mapping, when you are assuming. Who is making some noise? I think Nisa Chaudhary. Let me mute her. Okay. So there should be no element remain if you are assuming that set as a domain and taking a map of whatever in the codomain, so there should be no element should remain in for the taking the image. That means mean to say for each element there should be a image, one thing, and the say another thing is uh, for each element there should be not, this should be not the case, like for this single element you cannot get the two different images. These two cases will not should not happen for a relation. Then we'll call that relation as a function. That's all. This is the definition of saying to be a function. Sorry. And now once there is a function, it have two properties saying to be like 1 and onto. When we call a function as a 1, and here is the first lecture is on saying to be the 1. So we have already know the definition. We just discussed the tests, and definition mean to say when a function, the mathematical definition is generally before to mathematical the pictorial form mean to say a function. Suppose this is a function, and then function will call as a 1 function when for this element, if you are getting image, this image should be unique, the first thing, and it is the not case like this. It should be not like two images unique, like
One
you
image can
are
be
getting image for two
sorry,
Sir, your
different
voice is breaking.
elements.
your
It
voice is
should not happen like this.
Sir, your voice is breaking.
It is happening. Sorry.
Yes, yes, sir.
black.
Okay. Now hope is it clear now? Is it?
Yes, sir, clear now.
Yeah, sir, it's better.
Sorry. So this should be not case for the 1. I mean to say for two different input, you will not get the same output. If it is happening, then that function is not 1. That's the one thing. And there are different tests there before too. Like this is a like pictorial meant to say in the different set form kind of. The definition of mathematical definition is, suppose you have a function from a set A to B, and you will call this function as 1 when this should have this condition should follow. If it is assuming, you are assuming if let's say sorry, A and B elements of the domain and word and f of A equal to f of B is happening, then in that case this implies A equal to B. This should happen. Or differently, in another definition, A and B elements of the domain, okay, of the domain of the set A, and if element of the domain A and B, A not equal to B, this is happening, okay. If A and not equal to B is happening, this implies f of A not equal to f of B. This should happen. This is the first like condition is this should happen implies this one, and if it is happening, if this is happening, this implies this one. Okay, so be careful with this definition. This one implies this, not this one. Okay.
Yes, sir.
And the another one is this one implies this, not the reverse form. If these two cases is happening, then you will call a function is 1. For example, you can say this is the definition, mathematical definition for 1 function. And for example, you can think fx as 2x or maybe x cube itself, or 2x cube, or 2x plus 5. These functions are 1. You can easily check it with this definition. Okay, assuming to be as, let's say you can assume that, see, this function is, you can assume from R to R, and you can take two real number, let's say A and B belongs to R. So such that you can write like you can write like this, such that A, such that f of A equal to f of B. Okay, and anyhow I have to solve and reach to A equal to B. You have equation, this equation is given, and you have to solve and you have to reach anyhow. This says A equal to B. If you are reaching, then that's fine. If you are assuming f is this one, then f of A equal to going to be 2A plus 5, and f of B is going to be 2B plus 5. And anyhow, now you are solving that equation. So this is going to be cancelled out, and slowly one by one step, you will reach A equal to B. To see that this, you assume that this one, and you reached to a final destination as definition says. In that case, you will say this function is 1, 1. This is a process to check 1, 1. This is a mathematical or algebraic definition, you can say. There are now tests. So what is that test? Mean, if you have a graph of a function, if you are able to draw the graph of a function, and not only def function, assuming to be the, if you are able to draw the graph of a relation, that would be more broader way, you, if you want to say, because there are two tests. One is vertical test and another one is horizontal test. So vertical test, is to check a relation, to check a relation. If you are able to draw the graph of a relation, to check a relation is function or not. So suppose you have a relation, let's say I'm assuming that, let's say f from a set A to B, let's say this is not a function or relation. Okay, so be careful with the relation and function. So suppose this is a relation, okay, and I'm making this relation as, so relation, it will be in a pairwise. So let's say A, f of A. Okay, this is one sorry, this is one element in f in a relation, and another one is B, f of B will be, so we don't know what is exactly, but so this is going to be your pairwise. So here is not only f, here is, you will say graph, or means, or you will say okay, fine, this is, you are writing in a notation form. Okay, yeah, f is going to be, this is the value. Okay, so don't be confused. This relation, this is a relation, so you are getting input and this is output, so this is the value, so don't be confused. And this is f, a relation. And next one is B, f of, you are getting differently, let's say C, and rest all I don't know what is, but that's enough. So if you draw the graph of this relation, so this is, let's say this is A and this is f of A, fine. Okay, and this is suppose B and this is f of B. Okay, and again you are getting B as C and C, and suppose here is C. Okay, so if you draw the graph, so here is f of B. Let's say in between you have some input, and anyhow you are able to draw the graph like this. Suppose by luckily you have some more element. I didn't have representation, but assume that this is going to be the graph of this relation. So now vertical line test says, so vertical line is you should to draw a vertical line which should be parallel to the y-axis, and it should try to intersect the graph of the function. So if you draw this, or from anywhere, if you are able to, sorry, if you are able to draw the graph, and you took a vertical line test there. So if you see that this vertical line, if you see that passing through B, this is B here, this is A, and this is C. So this point is going to be BC, and this point is going to be f of A, this is P, f of B. So let me erase now some line. So suppose this is C here. So if you see that this graph for the graph of this relation is past the vertical line test. In that case, this is not a function. As big reason is also, you know, as you are for two in for unique for a input, you are getting, see,
आ रही
you
हूँ,
have
आप चलो, आप चलो, मैं आ रही हूँ.
let me mute. Okay. So you have input, and if you see that for this input BB, you are getting two different output. This f of B not equal to f of FC, as you are getting different output here. So this graph of this relation passed the vertical line test. So this is called the vertical line test. If you draw the graph vertically, and that should intersect the graph at least. So if that graph is intersecting at 2 points, then that means you will say that vertical line test is passed, and in that case you will say that relation is not a function. So this is the vertical line test. Now, so vertical line test is to check if relation is a function or not. So I to check a relation is a function or not. So this is for vertical line. Now another thing is horizontal line test. Okay. So horizontal line test is this is more ahead thing of this vertical, mean to say you have already a function. So this one says a relation is this one is for checking function. Now this horizontal line check to check a function is 1 or not. So it said you have already a function to check is this
Sir?
function. Yeah.
Sir, if it passes vertical line test, then that's not a function, right, sir?
So that's not a function.
It's a relation.
If the graph does not pass the vertical line, say, then you will say, okay, this is a function. That relation is actually a function. Okay.
Okay,
If
sir. Okay.
if it is not passing the vertical line test, then you will say that relation is a function. Once it is a function, then the next thing you need to check is this one. So in that case, you will use the horizontal line test. So to check a function is 1 or not. Function is 1 or not.
Sir,
Yeah.
I'm a bit confused here. If it passes the vertical line test, so it is a function or it is not a function?
If it is passes the vertical line test, then it is not a function.
It is not a function. So vertical line test says that there can't be 2 points on the line, right?
Yeah, that on the line. I simply mean to say you are getting two different image for a single input. For single input, you are getting two different output.
Okay.
But it should be not case for the function definition, as in starting I said.
Right. Okay. Okay. So vertical line test is we can't have 2 points on the vertical line, and whichever relation fails this test, that means it's a function.
It is a function.
Okay. Okay. Got it.
Okay. And horizontal line is to check a function is 1 or not. So what is horizontal line test? You are able to draw the graph of a function. Okay. If you able to draw a graph of a function, if you have already that, so already I have given the definition, algebraic definition, you can say, to check a function is 1 or not. suppose you are lucky and you are able to draw the graph itself of the function. So if, see, once you have a function and if you are able to draw the graph of function, that means everything is clear. There is nothing, there is, why the needed? If you are able to draw the graph of function, now the function is totally open. Everything, you can know anything about that function. And many, like end behaviors, axis of symmetry, or roots, or all, whatever the all things are there, everything is, you can, everything, those things are only to draw the graph of a function. You will use those tools as a to drawing the graph of function. If once if you are able to draw the rough, at least rough diagram of a function graph, rough diagram of a function, graph of a function, then that function is totally open. You can think any, like whatever you want to tell about that tangent or any property you want to tell, you can easily while looking, because you are able to see itself that graph. Anything you can tell. That's why these tools, this, you can directly tell that, okay, this is going to be 1 over or not. So suppose you are lucky here that you are able to draw the graph of function, and once you have a graph, just draw a horizontal line. So suppose, see that what is happening here. Somewhat. So see, already you know this is x values are input, and this line is for output, means f of x. These values you will get output. So what it mean that, see, this value is, suppose here, this is, let's say, a, and this value is exactly you are getting f of a. Okay, the same value, because as here the same value you are getting for, let's say, this is b, the same value here you are getting the same value. So what is happening here now? This is again f of a. So if you remember that, suppose here is b and here is a, sorry, here is a and here is b, and this is f of a. So what is happening? This one and this one. As in starting, I said, if it is happening, you will not say this is a 1. So see that, and rest all you can also see that this is happening for the same. Suppose this is c, so same value are getting for many point, for many input. So in that case, your function is not 1, 1. That's why this horizontal line test is very, it is very much useful if you have the graph of a function. So this is the horizontal line test. And already I have discussed the algebraic notion. Yeah. Yeah, your voice is breaking for me or for all of you.
For us also, sir.
Yes, sir. Voice is not clear.
Okay.
Hello,
Yeah. Hi.
sir.
Yeah,
I
hello.
had a doubt in activity 5.2.
Okay. What's your doubt for? Sorry, 5 point?
Question number 4.
Okay. Let's discuss this one. Question number 4. Okay. So let me, okay, this is already some example. Okay, fine. So we have already done the these 2 lecture, because this second lecture is just for example. So we very much know the 1, 1 function and the tests. So let's say discuss the first question. So which question, this fourth question, what's doubt here?
Sir, option number 1. How is it 1, 1?
Okay. So you want to check it, is this 1, 1 or not? How we will check it? Is this 1, 1 or not?
Yes. Yes, sir.
So is this 1, 1?
No. Yes. It's 1, 1.
Yes, sir, it's 1, 1.
So how we are checking? Why this is 1, 1?
Substituting x is equal to x1 and x is equal to x2 and equating these two, and we have to see whether x1 is equal to x2. If they are equal, then it's 1, 1.
Yeah, that's one thing. And are you able to draw the graph if you are do that for the vertical line test? No, it's difficult to draw the graph of this function.
Yes,
Let's
sir.
do the algebraic as we discussed now. So we have function this one. F of x is equal to 4x plus 3 and 3x minus 5. So assume that, so this is given, the domain of the function is given as removing the 5 by 3 only. So assume that, yeah, we have, let's say x1 and, or even let's say a and b from the domain as given are set minus 5 by 3. Okay. So let's say domain, two element from the domain such that f of a is equal to f of b. This implies 4a plus 3 upon 3a minus 5 equal to 4b plus 3 upon 4b minus 5. Now from here, what we can do? We can cross multiply. Let's solve. Now we have to solve and reach to anyhow a equal to b. Let's do that. So this is going to be multiply up to cross multiplication we have to do. So this is going to be 16ab. Oh, this is 3 here, I think. So this is 12ab. And this is minus 20a. And this is going to be 9b. And this is 50. This is equal to, again, 12ab plus 9a and minus 20b minus 50. So can we cancel out this one, this one, this one, this one? Okay, fine. That's up. Now this is, let's send this one to this side and this one to this side. So this is going to be 29b equal to 29a. Am I right here? So from here you can conclude that a equal to b. So yeah, fine, everything is fine here. A and b can be 0 also. In that case, still it is fine. So see that you assume that f of a equal to f of b, and anyhow you solve and reach to that condition. Okay, finally implies case. See that this is imply now happening. You assume this one, this implies this implies this, and finally you can say this implies this, b equal to or a equal to b. So that then you can say this function is 1, 1. Is it clear?
Sir, in one
Yes,
of
sir.
the lecture,
Yes,
sir,
sir.
in one of the lecture, Nilesh sir, he mentioned like we can do the check like this also, like we can take the numerator as a one term and then denominator as another term and then take it together as a one term. And then you check whether each term is 1-to-1 or not.
Oh, okay. So assuming to be this one is a function, a different function like this.
Yeah, just take it as a one term, 4x plus 3, and then another term, 3x minus 5.
Okay.
And then we have to take it as a one full
Whole.
term. So
Yeah, so this is 1, 1. Actually, this is 1, 1 also. Okay.
yeah.
So is this
so
work
if we
for
go-
every function?
Yeah.
Will it work for
Yes.
every function?
So we have to
Uh,
check all the three conditions in that.
What are the condition like?
So all the, like, for the numerator we have to check, for denominator we have to check, and then we have to take it as a full fraction.
Okay.
Like for
In
if you take it as a
full-
fraction, then x will like x should not be equal to 5 by 3.
There are lot of checks to be done.
Sorry, 3 by 5.
Algebraic equations
Five by
is
three, sorry.
good.
Hmm.
Yeah, this
Okay.
method which you said, it's always like give
Yeah,
us
actually,
correct
I
result.
know only this one, and it is at many places you usually
Yeah, in the
reject.
books also it is, this one is there. Yeah.
Okay. So actually, this one is helpful, but yeah, I don't know this one. Okay, sir, I have discussed. I will see it once again. Let's see. If I will get, then I will repeat it with a different method if I will get. Okay. Okay. Now next is yeah.
I have doubt in third question, sir. Same 5.2 activity. Third question.
Okay. What's your doubt here?
Why the fourth option is not a decreasing function?
So you can draw the graph. What is the graph of 1 by x? it is like this, right? How it is at 0 you are not, but as your number is increasing, your value is decreasing, and your number as increasing, so it would be like this in the positive scenario, in this portion, x and assumed to be f of x. And in this case, if it is negative, so if it is a smaller number going to 0 and your number is negative, so you will get the bigger number as 1 by x. And if your number is very small, then your value is going to be 0. So this is the graph of 1 by x. Now from here you can compare. So this is the case for this one, not like this. This is not the case here. This one. This is like this, and this is yeah, this one. So now can you tell me, is this increasing or decreasing? As your inputs are increasing here, so is
The
this
value will-
increasing or decreasing?
Decreasing, sir.
It is decreasing.
It is
In this
Decreasing,
part,
sir.
in this part, it is decreasing. But what about in this part?
both. It is
In both parts.
increasing.
Yeah, actually it is, as the numbers are going to be, this side is mean to say very small number, right? These numbers are bigger, 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 bigger. Like this is actually this is happening. So this is decreasing. No? Yes. Is it clear? From while drawing the graph.
Yes, sir.
So, sir, for one function, it should be either increasing or decreasing. It can't be both.
So yeah, how it could be that increasing, decreasing both? It should be either increasing or decreasing. One theorem is that if it is increasing function, then it is 1, 1. I missed that theorem. So the simply reason is you can easily prove that. That is not tough thing. So if you suppose your function, you have a function from a set A to B, and if it is increasing or decreasing, in that case, in both cases, so in both cases, your function is going to be 1, 1. So this increasing means this is the not case. Suppose A and B are elements of the domain, and this should not the case. Greater or equal to not. Strictly greater. In that case, it will happen. So if it is say that, and here is the case, let's say A is greater than B. If it is A is greater than B and f of A is greater than f of B, then it is increasing actually. And in this case also it is 1, 1. Simply reason, if you check that A not equal to B implies f of A not equal to B. See, this is the increasing means A is greater than B. A, this is the case not equal to B. And this implies also it is happening A is strictly greater than B, means this is also A not equal to B. So it is following the definition itself. Simply, there is a simple proof of it. So that's why it is 1, 1. If assuming to be A is greater than B and your function is decreasing, what is the definition of decreasing? In that case, f of A less than f of B. Values are in the input increasing, but your output is smaller. This is the mean. So in this case, again, as here A not equal to B is happening, same as it is increasing. Input is increasing, A not equal to B. You are getting, yeah, f of A not equal to, as here is not equal to, greater, not smaller, not equal to sign also. This is strictly decreasing. So again, it is 1, 1. So this is the decreasing case. And in this case, also 1, 1. The same definition of increasing and decreasing itself says the function is 1, 1. Is it clear? No,
Yes,
yes.
sir.
Yes, sir. Clear.
All of you?
Yes, sir.
Yes, sir.
No, sir. एक बार फिर से.
So here is no, where you are, which part you are missing?
Sir, this increasing or decreasing.
Okay. So let's say, okay, so increasing means your input. See this, that's why I said A and B from the domain, and this is the input. Let's say f of x is equal to 5x. Okay. Now compare with this definition with an example. So I am taking two input. Let's say x is equal to 2 and 5. So here is 5 is greater than 2. So here A is 5 and B is 2. Okay. Now find the value of what is going to be f of a. This is going to be 25. And f of 2 is actually 10. So what is happening here? F of 5 greater than f of 2, as 25 is f of 5 is 25 and f of 2 is 10. See that?
Yes.
Okay.
Got it?
Okay, sir.
So the function
And this is
increasing.
increasing function. This is an example. You have to check for all. That's why you have to assume for any real number as
Sir,
here.
this is for increasing. If we say any another example and it is decreasing, so we will see that B is greater than B is less than A till it's like you say na
Mhm.
2 is equals to B and 5 is equals to A and
Uh-huh.
B is less than A still
Mhm.
the f of B is greater than f of A.
F of B is greater than. Oh, so this is for decreasing case.
Yes, sir. That's
Okay,
what
no, so sorry, increasing case. Yeah, f of B less than f of A. Simply remember this sign. If it this one, don't be confused. A greater than B, f of A greater than f of B. This is increasing. Okay.
Okay,
If A is greater than B, but f of A less than f of B. If this is happening,
yes, sir.
then decreasing.
Okay, sir.
If same sign is happening, then that case is increasing. This is image, this is image. If it is image is reverting here. If it is that sign is reverting here according to when you are getting the image. So in that case, it is decreasing. And this is for any general, for all or real number. We'll check
Okay,
for A and B for all domain. If you are saying to be in a particular domain, your function is increasing or decreasing. In some interval, you are saying the function is increasing or decreasing.
Sir,
Hmm.
sir, can you give decreasing example?
Simply you can take your minus, no? F of x is equal to, let's say, f minus. F of x is equal to minus 5x. Now think about it. Is this increasing or decreasing?
Yes, sir. And x equals to, if we take 2, it is decreasing.
Yeah.
Okay,
It
sir.
is decreasing.
Got it.
So, and hope you got the idea, mean to say when it is increasing or decreasing, why it is 1. Simply is the same, the exact definition itself. From definition, it is saying, okay, this is 1. But both cases, increasing and decreasing. Okay, let's move to the next thing is exponential. So in exponential, there is not much. There is just a definition. I am not going to tell the origin thing because origin is mainly arised from the x, that e notation as e. Where is that? E is some value. E is equal to some. What is that? 3 point something. Some value is
No,
there.
sir, it's 2.71.
2.7.
2.7 something is there. Yeah, the value of e is between 2 and 3. Yeah, 3 and 2. This is c. 2 point some number is there. Some value have. So actually, this exponential came before 2a. Mean to say, if you have a function fx, see many, like already, some linear, some quadratic, some polynomial, and in the fraction part. So in the fraction part, so there can be a case as here when you are studying in the polynomial, the variable is the below part and the constant term or constant term or real number part is as the power of the variable. So can we revert it as in this form also? So whenever it is happening, so this one kind of exponential, like now from here you can say, like, as here the base is variable and the power is some constant number, but once you revert it, so this is, you will get a new function. Now this is another function, that this such kind of function called exponential function, but it have some constraints are there, like the reason is also there. You cannot now yeah, so there are some constraint that whenever we talk about the exponential function, so that whatever the base as here, as we are taking as a constant and power as a variable, so base should not equal to 0, you can assume, and not even negative also. Not even negative, a should be always positive. You can assume a is equal to 0, that's enough, but still why we are assuming a not equal to 0 means because we will get 0 itself, and not a negative. The reason is not negative because if you assume a is equal to -2, okay, and if you think about -2 the power x, and you are thinking x from any real number, a domain as a real number, so in that case, if x is equal to, you will take 1/2, so you will not get a real number. This is a root of -2. Exponential you will get, sorry, complex number you will get. That's why the reason a should be greater than 0. And another thing is a should be greater than 1. Sorry, a should not equal to 1 also. The simple reason is, you can say again as for the 0 case, because that's the obvious thing. So for whenever you talk about now the exponential function, so assuming to be a to the power x, where a is any real number, but it have sorry, x, you can assume any real number, but in the base case it have some constraint, which is this 0. You can, let's for the time being, you can remove that 0 greater than, strictly greater than 0 and less than 1, and another thing is greater than 1. For these cases, I don't know in the video is sir to strictly greater than 0 or only greater or equal to 0?
Strictly greater than 0.
Strictly greater, because we need to remove the obvious cases. You can assume greater than, strictly greater than 0. You can remove the obvious case. Yeah, it is strictly greater than 0.
So
Sir?
in this case, there is no
Yes.
direct way to answer this.
Yes.
So actually, I did not get this part. Why can't we take a as negative? Like
Negative.
yeah, because like how you said -2. So if
Mhm.
suppose I have a number -2 raised to x, and that
Mhm.
x is 2. So -2 square is 4, right?
4, that's fine. But
Yeah,
if you assume x is equal to 1/2, then
x is 1/2, then that would be 1/4.
no, if you are
You're
assuming
thinking
-2 1 over 1/2, so what, it's still you are taking the root, some you are taking the root of a number, of a negative number, and this is not a real number. In this case, you will get a complex number.
oh, you mean you're taking half as the power?
Yeah, half of the power.
Oh,
Yes.
okay. I thought you're taking it as a number. Okay, got
No,
it, got
as a power.
it. Yeah, okay,
So
got it.
that's why you need to assume a is a positive number, not even neutral, means 0.
All
And
right.
also you need to remove the one thing, 1 as an a is less than 0 and greater than 0. Sorry, a is greater than 0 and greater than 1 also, less than 1, greater than 1. So if you have, so this is the definition, exactly definition of exponential. You have function fx is equal to a to the power x. Okay. So, and you can assume
Sir, your voice is not coming.
Yes, sir, you're not audible, sir.
Sir, you are on mute.
Hello.
Just a minute, just a minute. Oh, okay. Sorry. Okay. Let's continue. Sorry for interruption. I hope there is no issue. Can we continue?
Yes, sir.
Yes.
Okay, so yeah, we are talking about the exponential function. So yeah, so there are some constraints. This portion, this should be happen. Now the main thing is here, only once you draw the graph. So as you know, if you take 3 to the power 2 is 9, 3 to the power 3 is going to be, I think, 27. 3 to the power 4 is going to be 81, I think. So see that as you think these are the integers, so we are able to do that all. One thing, and another thing is if you See, the base is fixed 3, 3. If you think x here, the power is kind of variable. Here is variable you are taking as an integer. If you think if this integer replace integer with the real number, so you can think this one 3 to the power x, where x belongs to the whole R. Suppose you have function this one. F of x is equal to 3 to the power x, and x belongs to R. This we have. Okay, so as you know, as here the values is increasing. So as your values increasing means, if you have roughly some idea, if you think x to the 3 to the power minus 1 also, it is going to be 1 by 3, smaller values. So it tells you like these are some guessing things. If you guess that, so somewhat the graph of e to the power 3x, you can think this is kind of like as values increasing, you will get very large and large value, and as value is smaller, which is going to be minus infinity, you can say very small number. So like if you think f of x, sorry, here is x to the power, sorry, 3 to the power minus very big number, if you think that. So this could be written as 1 by 3 to the power this one, like this. This could be written as this one. So this is a very small number. Mean to say value is here 0. It's coming to 0. So roughly you can draw the graph. This is going to the graph of, you can think, e to the power x. And again here some terms came, y-intercept, x-intercept, x goes to infinity, positive infinity, x goes to minus, negative infinity minus. And so as here, once you substitute here, y-intercept is actually 1. So not even for only 3, it is true for y-intercept is 1 for any a to the power x. If you substitute here a is x is equal to 0, you will get always 1. So y-intercept is 1. There is no x-intercept, because if you see, if you assume that 3 to the power x is equal to 0, so how you will get that? What is the value of x which give the 0 value? So it will never happen, as if you substitute any value, you will never get 0. And 0 means here the root, yeah, or x-intercept. That means there is no x-intercept. And another thing is there is no x-intercept. So this is for 3 to the power x case, but this is true for any. Whatever you are talking about, this is true for any a to the power x. The constants is a is in this case. So this is the graph assuming to be the a greater than 1. The similar graph for any a to the power x. And the y-intercept same, there is no x-intercept. And as the x goes to infinity, f of x goes to infinity, as this one is, we will get very large number. And as x goes to minus infinity, goes to, as well, is very substitute here very small number. So this give you will get a 0. Means 0 means very small number you will get as an output. Not, you will never get 0. You will never get this.
Asymptote to x-axis.
So asymptote. There is one word, asymptote. So this x-axis is going to be asymptote. And next is y-intercept, x-intercept. That's all about. And another thing, when a is less than 1 and greater than 0, in that case, it will revert. And this is the only thing. Here is again y-intercept same, x-intercept, there is no x-intercept. Only differences is as, so this is not the case here. This will not, this sign will come. You are getting, the number is increasing in this. This is the case. As x goes to infinity, you will get a very large value. Simply reason, if you think a is equal to 0.5, means 1 by 2. So if you substitute, take the power of very, let's say 5. So it will give a 1 to the power 32, which is going to be smaller somewhat. And if you take 1 by 2 the power 2, so it's going to be 1 by 2. So 1 by, suppose here is 1 upon 32. So here is 1 by 4. Oh, sorry. This is 1 upon 4. Yeah, sorry, that is correct. I think, yeah. This is going to be 1 upon 32, and this is going to be 1 by 4 value. So as the value is increasing, you are substituting very large number, it is coming to the 0. Again, x as an asymptote in the positive side. And as if substitute minus a negative value, it will revert. Like suppose here is again 1 by 2 to the power minus 2. So you can differently write as 2 to the power 2, which is 4. This one is actually 4. So you're getting some large value. Similarly, as you are getting as very input as a small number, means this side you will get larger and larger value. So that's why you can think for this is the case for a greater than 1, and this is the case for a less than 1, less than 0. This is the graph. So not this side. This is always like this. This side. So this is all about the e to the power x. I think that's all. There need to solve some. Yeah.
Sir,
Sir, is x power 2 or x power any constant exponent?
X to the power?
Any constant. For example, 2, 3 or something. Is that an exponent?
No, for such kind, no, this is not exponential. No, for exponential is the base should be constant, some real number, and power as any, it could be any real number. This is not the case.
Okay.
Here is the base is variable, and the power
So
is
this is square root function.
Yeah, this is actually a square root, and not even the polynomial. This is not a polynomial. I don't know what is. It is a different name or no? Nothing. This is a simply function. Okay. Yeah, we have some given some name exponential, logarithmic, or polynomial. Some name, but this is not an exponential. Somebody have raised hand. Okay. Mansur. Want to say something?
Sir, I have a doubt. Can I ask?
Okay.
Yeah, so sir, for the condition a is greater than 1, even if the power x is negative, then also it's an increasing function, sir.
A is greater than 1. And
yeah.
Okay.
Power a to the power x is negative.
Still, yeah, it is increasing, no?
Okay.
This is increasing function. See that as the value is increasing, the function value is also increasing. If you think in the negative part, this is the negative part of input.
Yeah.
This is the, if you see that this is going to be far away from the x-axis. This is the output line, right? The value are getting increased.
Okay, only if a is greater than 0 and less than 1, then it is decreasing.
Yeah.
Okay. Okay, sir. Thank you.
And Vikram want to say something?
Yes, sir. Sir, what about the power of x? If the power is 9 upon 4 or some numbers like that, can you give some examples?
Power
like,
means power. Sorry, can you repeat again, please?
So, if we have power like 9 upon 4.
9.4 to the power something or what?
9 by 4, sir. 9 by 4. 9 upon 4.
Oh, 9 by 4. Okay. To the power x.
Yeah, to the power x.
Okay. So simply, there is no problem. 9 by 4 is actually greater than 1. So 9 by 4 is greater than 1. Right?
Yeah.
So it is, we have similarly as a to the power x, where a is greater than 1. There is nothing. The same thing. Only what you will, some output value is different. Even x-intercept will be the same. Only the output values are different. Otherwise, the graph will be similar, very similar to the as for the general case, a greater than 1.
And if,
Exactly.
sir, we
similar.
have, suppose we have x raised to power 9/4. Actually, I was asking like that. X raised to power
This
9/4. Yes, sir, yes, sir,
Okay.
yes. Yeah.
So this is not a polynomial first, and even this is not a, sorry, this is not a exponential and not a polynomial. So this is, we done studied till week 1 to 4. So this is a simply, you can say this is a function. This is a function. And if you
Function,
want to know what is property, so you have to check, okay, why, if you want to do that, so you can say what is x intercept, what is y intercept. And if you want to draw it, you can draw also somewhat, like assuming to be okay. So this is a simply function. This is not exponential, not even polynomial, not quadratic. This is different. Whatever you have studied till week 5, this
Yeah.
is different, totally different. Not polynomial, not quadratic, not linear. This is not linear even. Linear function, not exponential. This is totally different. So you can think this is just a function. Now, you know, the tools are y-intercept, x-intercept, roots, in the behavior. Even you can apply here for this one, but you have to think about it. Like, what is x-intercept? You can put x is equal to 0. So for this function, even x and y-intercept are same, only 0 here is here. Now you are getting any other root? No, there is no, except the 0, x is equal to 0, there is no root. Now you can think about the int behavior. Okay, roots is only here. What about the int behavior? As x going to be positive and x goes to be larger number. So yeah, it will give the larger number because as 9/4 is greater than 1 actually. So it will be like this, increasing kind of. What about in the negative part? If it is negative, then there is a problem. If it is suppose x is equal to -1, then it is going to be -1 9 to the power 4. It keeps some kind of, now it will give, see, this will happen -1 to the power, you can think it is like this, okay, 9 1/4. Still it work. And this is going to be -1, so it will give 9 even -1 itself. This whole thing give -1 to the power 4. So what about the root of sorry, not root, 1 to the power 4, sorry, -1 to the power 1/4, what is the value? It has some real value and even some complex value also.
Complex.
So you will don't think about the negative side, only you can think about the positive side. So you will know, you say the domain of this function is generally, you will say x is greater than 0, and the graph will be like this. That's all. This much you can tell.
Okay. So in
If you
maths
want
2
to,
also, we are not going to study the complex numbers.
yeah, in maths 2 also you will not study.
Okay.
Okay, yeah. So I think there is, I missed the part, some property of the power, some like this one, a to the power t to power os. What is going to be this? Where a is any, assuming the best thing is in the domain, whatever the exponential function domain. Okay, in that domain, a should be greater than 1 and a is like this. In this domain, you can think. Even for 1 also, you can think. For, you can assume that a is only strictly greater than 0. For that case, it will follow. And if it is happening a t to the power s, so this is going to be somebody, yeah, Wes or Muhammad Asifa. Do you have doubt here?
Sir, hello sir.
Okay.
I have doubt in activity question 5.5.
Okay.
Sixth question.
Okay. Any properties remain here? I think this one done, these 3. Okay, these 3 properties. Okay. Activity 5.5.
Yes, sir. Question number 6.
Okay, can we discuss a little bit after 10 minutes? Because now I am going to start the exponential, natural exponential.
Okay, sir. Okay, sir. No problem.
Yeah, then
Sir?
we'll do. Yeah.
So I have doubt in activity 5.3, sir.
Okay.
Sorry, activity 5.4, sir. In that last question, can you explain, sir?
Okay. Sorry, Vas is want to ask something, Vas.
Yes,
Last
question number 4 from 5.4 activity.
Okay, 3 and 4.
Yeah.
Okay. So, okay, this one is for, let's say, for the third one. This one, I think, for Mansur. No? Yeah, I think. The fourth, the third question, right? 5.4, third question. This one. Someone has asked this question, no? Third? No.
Yes, sir, this one.
Okay. Okay. So what's your doubt here? No reply. Okay. If you will not tell, then how will know what's your doubt here? Otherwise, I will go to the fourth question where I have asked, I think. Okay. What about the fourth? What's doubt here in the behavior of this? Yeah.
Yeah, like I have doubt like x is approaching infinity, so it should be 0, no? That why it is like 15? That I don't understand.
Okay, you have function this one. This one. So,
yes.
like if you suppose you have a function f of x is equal to ax plus 5, let's say 2x plus 5. So what do you think? What is difference between 2x and 2x plus 5? Suppose 2x is this one. So 2x 5 is just shift 5 unit. That's all. Otherwise, lines will be parallel. Now,
Okay.
similarly, if you think about this
Like-
one. Yeah.
If like there was like no 15 there, so it will be 0 then.
If it is going to be now, if you are, so you know that as you said, this is goes to 0 as x goes to infinitive. So it is 0, but each time you are adding 15. Each time you are adding 15. That means it should approach now. The whole thing is approach to 15.
Okay. Okay, sir. Thank you, sir.
Okay. Okay.
Sir, I didn't get it. Can you explain it once again, sir?
So this one, the same is. You
Yes,
can
sir.
think this one. Are you getting this one? For suppose this is for 2x. The graph for 2x. And when you added 2x plus 5 here. So what is the difference in the graph? It is just shifted 5 unit. That's all, no? The same, very similar. It is just shift of 2x. Same thing is happening here.
Okay,
also.
okay, sir.
Only shift of 15 unit.
Okay,
but
sir.
the whole property is very similar to 1 by 7x. Okay.
So, and then fifth question, sir.
Okay. Mansur wants to say something.
Sir, I have a doubt in exercise activity question 5.1.
Okay. Okay, we'll take. Okay. So
number
fifth
4.
question of this question also. This activity. Then we'll
Yes, sir.
go back to 5.1.
Yes,
Okay.
question, sir.
What's the doubt here?
Sir, how the answer is option 3, sir? Why not 2x, 2 power x, 3 power x, 5 power x?
Okay. So no, so here is this one is f.
We have to match the FGH.
Yeah,
according to the
that's all.
option.
You have to match. Like, why this is see, what do you mean by this somewhat more raised or steep, even this one with respect to this one and this one? So that means what?
Bigger the value of a, more
Yeah, you are
rapidly
getting,
it will increase.
Yeah, if it is happening this one, a to the power x. So if suppose a is equal to 2, a is equal to 3, and a is equal to 5. So if this case is there, now think about a to the power 4. Like for this case, assume x is equal to 5 for the all three. Not even 5. Let's assume x is equal to 2 for all three. So this is going to be 4. This is going to be 9. This is going to be 25. So suppose here is 2. So for a is equal to 2, it will be here. For a equal to 5, it will be here. For a equal to, sorry, a equal to 3. For a equal to 5, it will be here. So what is happening here? It is more steep. Like this. Okay, I made it mistake here. So that means whenever the base is increasing, the graph will be more steep. That's the mean to say.
Okay, sir.
That's why now you can compare. If it is this one is greater than with the compare of other one, the graph will be more steep. It is going to more faster than other one.
Yeah. Okay, sir. Got it.
Okay, someone have 5.1 have doubt.
Sir, question number 4, option number 4.
Question number 4, option number 4. A function is called 1 if it is this. So why this is not correct or false?
Why this is false?
So in starting you were there when I was discussing the definition of 1 no? This one I was discussing when you will call a function is 1 you will not get the value, like mean to say 1 is a equal to b implies f of a equal to f of b. This is not the case. The case is when a function, you will say a function is 1 when x1 not equal to x2. This implies f of x1 not equal to f of x2. Not the case this one, x1 or f of x1 not equal to f of x2. This implies x1 not equal to. This is not case for 1. This is for 1, not this one.
But this is reversible, sir.
No, not reversible. You cannot revert the definition. These have different. Please think for this. For this one, think about the question. The example is let's say simply x square itself.
Okay, got it, sir. Thank you.
Think about x square with respect to this one. This follows this one, but x square is not a form 1, right? This condition followed by this one, but x square is not 1.
Yeah.
Okay. Someone have okay. Raj Deepak.
Yes, sir. Sir, I have doubt in property, sir. Property number 1.
This one.
Yes, sir.
What's doubt here? Just you will add.
Sir, in property 1, sir, in property 1 of there is b in a term.
No, sorry, your voice is breaking. That's why I didn't get. Can you repeat again, please?
Sir, what if there is b in any one term?
B, where is B? In this property? Where is B?
Yes, sir.
Okay.
What
if it is like
we
this.
take b in any one?
This one.
Yes, sir. Yes, sir. Right.
So in this case, you will not apply. Your formula is will done with this one. If the base is same. Not for you. There is no chance. What you can do? Nothing.
Then how to solve like problems, sir?
So then you have to think about that. You have to manage, like suppose the case is here. Suppose a equal to 2 and b equal to 4. Okay. Here is a and b are different. Okay. Now it is the question. 2 to the power 5 into 4 to the power 10. So what is going to the value? So what you can do? You have to do something. You have to try to make the base because you have only this property. Anyhow, you have to reach in our property, in our domain, so that you can
Sir,
solve.
what if there is 3 instead of 4?
So now you don't have any, like there is no chance to do. You have to find the exact number. Otherwise,
sure.
suppose if there is 4, then you can manipulate it. What you can do to the 2 to the power 5 into 2 to the power. This you can make.
Yes, sir, that we can do that.
You can do, but if it is different, then you can now. Then you have to find the final number.
No, sir. Okay, sir. Thank you, sir.
Okay, let me see. Vikram want to say Rajdeep.
So Vikram here, sir.
Yeah, hi Vikram.
Sir, hello, sir. Sir, in the candidate was asking the last question of activity 5.1 of question number 4, the last option, as you were telling that you cannot revert the definition.
Yes.
So in the video, sir, the Nilesh was telling about the reversible function concept, something.
So when you will revert it, but the case is for the definition, you cannot revert it.
Okay. But
for checking
sir,
this is not that.
Okay. I am asking, sir, when we will use the concept of reversible function?
No. So for reversible, okay, for reversible, you will use for checking the relation is 1 over or not.
Just for relation.
For relation. This is this tells you the relation is function or not. If you are getting 2 different output, your input should not be the same.
Inverse is possible only for one-to-one functions.
If you are taking the reverse case, then for 1-1. But if you are assuming this one case, if you assume, so this case is only you can use for the checking or relation is a function or not. This is the same meaning says you are getting different output when your input is different. Okay, if you are getting different output, when your input is different, it is saying the definition of relation. This is actually, you can think, sorry, for when your function is a relation or not. Sorry, your relation is a function or not. This definition you can use only for checking a relation is a function or not. This is for not 1-1.
Okay, sir. Okay, sir. Thank you, sir. Thank you.
Okay, so let's move to our new. I think let's move. Yeah, okay. New thing. Where is that? 1-1 exponential and natural. I am leaving because there is nothing. There is nothing. Just a special case of exponential. In place of A, you will replace with E. Every property is same. Every property is same because even easier than the previous one because E is greater than 1. E value is some between 2 and 3. Some 2 point some number is there. I can't remember, but yeah, this time. But yeah, it is the same thing. This is the case for A greater than. There is nothing. The same. E to the power x is actually called natural exponential, and it has the same property when A is greater than 1 to the power x. Exactly same, no change. So in exponential have very much similarity in the graph, and even property also y-intercept, x-intercept, end behavior, and roots, even root. X-intercept is tells about the roots, and anything more. That's all. Even follow the property of this power thing. This all property will follow by e to the power x also. So exactly same. We are only just stating the specific value of A, which is E, and E is actually 2 point something. That's all. The main, now let's move to the main thing, which is composition and inverse. I want to discuss that. It will take time there. And that's from the inverse. The new function you will See, because of the inverse only. As exponential, we discussed that it is also increasing function. So it is 1, 1. And once you have 1, 1 function, then you can invert that. You will get an inverse of that function. So we'll see the definition, then we'll talk about more the inverse function. Before that, we need to know composition. One by one step, we have to proceed. Once you know the composition, then we'll talk about the inverse, because inverse is nothing but the composition of two functions which give a identity function. Somebody have raised, I think. Yeah, Ayush.
Sir, I have a specific doubt on quiz 1, question number 68.
68.
Yes, sir.
In math 1. So what is
Yes,
the
sir.
question? Can you tell me
So
that question?
question says that a polynomial a graph of polynomial function given that and 4 options are there. First option, the degree of px is at least 10. Second option is px represent an even degree polynomial. Third one is total number of turning points of px are 8, and fourth one is multiplities of 0, and one of the negative roots could be same. So sir, I have a doubt in fourth option, the multiplicity of 0 and one of the negative roots could be same. So I think, sir, this option is incorrect, because when we see this graph, then it's one of its negative roots. So sir, in week 4, lecture 4.9, sir told us that when a even degree when a graph letter, then when even degree functions graph letter, then it's curve flatter. And sir, here we see
you
that
can speak in Hindi. You can speak in English if you have problem.
सर मतलब है ना इस ग्राफ में मतलब जो 0 पॉइंट है, 0 पॉइंट पर जो फंक्शन का कर्व है वो सर ज्यादा फ्लैट हो रहा है, फ्लैट, और सर इसका जो नेगेटिव रूट्स है उस पे फ्लैट हो नहीं रहा है, इस पे थोड़ा कम फ्लैट हो रहा है. तो सर मेरा इसमें जैसे ऑप्शन दिया गया है कि ये जो इसका एक नेगेटिव रूट है उसकी डिग्री, इसका जो नेगेटिव रूट है उसकी मल्टीप्लिसिटी, और इसका जो 0 पर जो मल्टीप्लिसिटी वो सेम होगी. तो सर मेरे ख्याल से ये होनी नहीं चाहिए, क्योंकि है ना ये जो नेगेटिव रूट है जहां पर है ना ये कर्व बन रहा है, तो सर यहाँ पर ये थोड़ा कम ब्रॉड है, लेकिन ये 0 पे ज्यादा ब्रॉड है. तो सर ये सेम होनी नहीं चाहिए, लेकिन सर आंसर की में ये दिया हुआ है कि ये 0 की दोनों की मल्टीप्लिसिटी सेम होगी.
It could be same. It could be same.
लेकिन सर एग्जैक्टली तो सेम नहीं है ना.
Same nahi, it could be. That's why there is a possibility. No, it could be.
Yes, sir.
Yeah,
Yes,
it is. See, it is a rough diagram, not exactly given in the Desmos.
Okay, sir.
It could be. That's why. So please don't be confused. I think.
तो सर मतलब मैंने एग्जाम में यही सोचकर है ना इस ऑप्शन को मार्क नहीं किया, मतलब कि मतलब ये थोड़ा कम है ये ज्यादा है, तो यही सोचकर सर असल में तो सर ये सही नहीं हो सकता, मतलब सर.
No, how it could be? It could be right. It could be 2, 4. So see, options are what? If you are following the like it is true, you can say that for that question it is a universal truth, then you will take that option. That's the meaning.
Sir. Okay, sir.
Like for the first option, it is true for any case. You do if you will similar kind of if you draw the graph we having like this. So options is like for the particular question, it is universal true, then you will pick that option.
Okay,
but
sir.
it could be, here is the possibility says, no? It could be also different or same
sir.
also.
Okay, sir. Okay. Thank you, sir.
Okay. Neha want to say something?
Yes, sir. I have a doubt in activity 3, 5.3, question number 3. How to solve it, sir?
5.3.
Yeah.
Question number 3.
Question number 3, sir.
Okay, this one, true and false.
No, sir. 5.3. Simplify the expression given.
Okay. Okay.
Yes,
Simplify the expression.
Yes, sir. How to solve it, sir?
So for this you have to like the same. So that's why I think one property I have missed. So yeah, this property. After looking this, the first property is a to the power s and b to the power x sorry, yes, the same power is same, then in that case, a b to the power x will happen. Sorry, yes, will happen. This is the fourth property. Using this property you can solve, right? This one. If you are the power is the same, you can multiply them. You can use the property as here, or you can separate the property also. If it is the whole, you can make it separate. So just simplify that. It is what it will be. It will be to the power 2 to the power 2 to the power 5. Okay, and it is, and next one is 3 to the power 3 power 5. And you can multiply them. So you can use one by one the property for the first term. This one and this one, or either this one is you can use this one. Yeah, this one, and yeah, this one also. These two property if you use, you will get that. What is that? 2 to the power 2 into 3 to the power 3, 5. So this is what? This is 2 to the power 5 into 3 to the power 5. So this is 2 into 5 into 3 into 5. So this is 2 to the power 10, 3 to the power 15. Similarly, you can check for other also. Anyhow you will make a same power and you will get that. Is it clear? Like you can change to this 4 as 2 and 2 to the power 14 it will come. It will be the same. Here is you can change 2 to the power 3. You can change this one 5 to the power square, multiply and separate those all. So do the operations and change this one in the form of 2, 3 and 5. That's all in 3 terms. Is it clear?
But sir, answer is 60 by 15. Then how it is possible?
So you will get.
Please, sir, can you
So,
solve it? If it is possible for you, then.
See, it can be easily solved. Either you can ask in this course also. It will quickly do that. Okay. The one part we have already did that. The first part is 2 to the power 10 and 3 to the power 15. The next part is 4 and this one. So this is 4 to the power 7 into 5 to the power 3. So this would be 2 to the power 10, 3 to the power 15. Let's leave this one. This is the same. This could be written as 2 to the power 40, 5 to the power 3. Is it clear? This one? How will you get that?
Yes, sir. Yes.
Okay. Now this one and this one, add these two. This is going to be 24. The power will be added. And this is going to be the 3 to the power 15 and 5 to the power 3. Now back to this portion. This could be written as 2 to the power 3 into 5, 6, the whole 2, I think. Yes. Is it clear? You can write like this.
Yes, sir. Yes, sir.
So this could be 2 to the power 6 and this could be 5 to the power 12. Now add here this one. This is the same. This one will be added. So what you will get? 2 to the power 26. Okay. And 3 to the power 15. And this is 5 to the power 15. Now you can do this one. This is 2 to the power 16 into this is 15 to the power 15. Is it clear?
30
13. Sorry, where is that 30? 30.
Yes, 30.
30.
Here is 30. Yeah, 30. Yes, this is 30. Now you can change this as something you can do. Now what you can do here? 2 to the power 2, 15 into 15 to the power 15. So this is 4 to the power 15 into 15 to the power 15. Again, you can do 4 into 15 upon to the whole power 15. And this is going to be 60 and this is going to be 15. Is it clear?
Yes, sir. Yes, sir. Thank you, sir.
Let's move on the composition of function. We'll quickly do that. Otherwise, only we have 30 minutes. Okay, so composition of function is composition. When we will do the composition, so let me explain with an example. Suppose you have function, let's say fx is equal to 2x and gx is equal to x cube plus 5. So composition means writing to be like this: f for f circle g. This means f gx. What it means that in place of exactly x for f, replace with g. That means f, replace here gx as directly, or either you can write like this. Two ways you can write like this. Either you can write 2 into gx. Now substitute value of gx, which is x to the power 3 plus 5, and finally 2x cube plus 10. Or you can write like this also. F, you can change the x exactly here itself, x cube plus 5. That means in place of x, we need to substitute x cube plus 3. So that means 2x cube. In place of x, exactly you can substitute this whole term. And again, you will get the same. As we here mean to say the same thing, we just jump here one by one here, or directly this one. So this is the mean of composition. You are taking the composition of two function f and g, where f as you can think as the upper portion and g as inner. So when we talk about the composition, there is one thing need to be note. The domain is very important. And there are two, whenever you take the composition of function, two condition always you have to check there. The first condition is suppose you have function f from a to b and another function g from b. So whenever you talk about the composition of the function, then this should happen. If you're talking about the composition of f circle g, whenever you talk about the composition of f circle g, that means what? Here, from here, you can itself think that whatever the output you are taking, sorry, somebody wants to say something. Okay. Whatever you want to take the output here, see, here is x is input and gx give the output, and output of gx is input of f. Output of gx is input of f. So here is one thing you have to be very careful, that output of g, which is you are getting set b. Output of g is you are getting set b. So output of this set g, oh, I think I am missing that. This should be like this, b to a. It should be input of that function f. Output set of the set g should be input of that function. Then in that case, you will think about the composition of function. And not only this one, you have to very careful with the range. So means here, not only this is a domain. So output, so that's why I'm saying output of g. So output of g is actually range of g. So range of g should be domain of function f. Okay, this should happen. And one thing is there when we talk about, so you will take, so okay, from here, this input, C is an input set. You will take those number as the input, okay? Those number as input. See, here is one thing need to be note here. You are taking the output as an input of F. Output of G, you are taking the input of F. So suppose somewhere your function is not defined for the F. Suppose the case is here, let's say fx is equal to 1 by x, in itself this one. And you are getting G some value of A as 0, where A belongs to C here. Think about, let's say A is an element of C, okay, such that G of A is equal to 0. Okay, I don't know what is exact function, but I know only the function f, which is 1 by x. So you will not consider A as the input for the composition of G, this one, because when you talk about, when you are taking this as this one, so at f of GA in place of x, at x is equal to A, you are getting 0. And at 0, this function is not defined, fx is not defined. So you will not consider, when you are talking about the domain of f circle G, you need to remove this A. This is one thing. So from this domain of C, you have to remove. And another thing is what? What is the next? I think I'm missing. The next one is, the next one is even the domain of even itself G. Even the domain of G function, means to say, suppose your fx is this one. Gx is, let's say, I have to get some, okay, for example, let's say x minus 2. So for r value of x, it is defined. So if you talk about the, so let's say for this example, let's say fx is equal to 1 by x and gx is equal to x minus 2. Okay, so you want to talk about the composition of f and g. So in the domain of, you want to find the domain of this function f circle g. This is a function. You are taking the composition of two functions. So domain of this one is going to, you have to remove this 2 from the domain. The reason is, when you substitute 2, you will get output as 0 for the case of f. For example, you can see that this is going to be f of gx, and now f of g2 is going to be f of 0, and this is not defined for the case of, as function f is not defined at 0. Now one thing more, let's say now for example, another example, f of x is equal to, let's say 1 by x, and gx is equal to the same 1 upon x minus 2. Just revert, let's take a different function, gx is equal to 1 by 2. So for this case, you will not take the domain as domain element 2. So domain of this function is going to be your r minus, you need to remove 2 from r. And anything more we have to remove? To add 2, it is not the problem. It's create a problem. And any other portion, any other place, rest all fine, right? Because now for each input you will get the some non-zero value, and f circle g will get a definite number. Now suppose for this case, now if you take the f circle g, am I audible?
Yes, sir.
Yes, sir, you are audible.
Okay. Oh, so now if you think about this function position of this these two function, then as this is not defined at 0, fine. And this one is not defined at x is equal to 2. So again, whenever you talk about the domain of this one f circle G, this is going to be your f of G is, see that there is one interesting thing will happen. This is going to be 1 upon Gx, and this is 1 upon x minus 2, and which is finally you will get x minus 2. So see, when you are doing this composition, you got a linear function. You will get a linear function. See that what is happening here. The linear function, if you only think about this one, the final thing is f circle Gx. This is exactly a simple function. Then you will say the domain of this one is exactly whole R, but not the case here because you are taking the composition. You are getting this function after taking the composition. So composition, when you are taking the composition, then domain will be not R. Now you have to remove 2 because at 2 this Gx is not defined. So domain of this one is not whole R. Even you know that this is, you will get the for whole R value, you will get for whole R, but your function is not simple function. It is the composite of 2 function. That's why you have to be careful with the domain. And in this case, in the composition case, your domain will be this one. So it is one interesting thing that even you will get a simple function. You know that this for this one, the whole R is a domain, but our function not, this one is not a simple function. It is composite. It is composition of 2 function. In that case, you have to take care with the composition part, that whatever this element part you can say, you have to be careful with that. Then now according to that, you have to decide the domain. This is all about the domain of function. Anyone had doubt here? Please let me know. If I'm missing something, also please let me know if you watch the lecture, if I'm missing something.
Sir, I want to ask something about this. Sir, where do we use like this composite function in real life? Like when the exams and the questions will come in the exam, the questions will be, I think, the real life based, right? So
May not be also simply also like you have seen, have already sir have solved an example of
so that
availing
this
offer,
offer,
availing
yeah.
offer. This is one kind of composition of a real life example. You can see that this is a composition of 2 function. You can think offers are a function, and then you are availing one offer, then 2 second offer or first offer as this one birthday or Sunday special offer, or this is on tutorial. So you can so that is an example. But composition, why use of the composition is to know the inverse of it. See why we are studying this composition, because without knowing the composition you cannot tell about the inverse. What is the definition of inverse function? So here is one. So you can say in the not even the real life, here is the use of composition is to find the inverse of a function. And from the inverse of a function, then once you know the exponential function, then very important function you got logarithmic because of this inverse of a function. And your inverse of a function comes from the composition itself. So you cannot take as an easy part thinking about the composition, Composition gives the inverse definition, and inverse is actually arised even a very beautiful function, logarithmic. And logarithmic is very, very much useful already, in many places you will see. So it is come from the composition. Logarithmic function come from the composition, you will see. So
okay, sir.
okay, this is you can think about the use of composition. So what is the inverse of a function now? So inverse of a function is nothing but a different function. Suppose you have function from A to B. Okay. Now suppose there exists suppose you have a function G. So here is when something we are around or we are playing around the composition function. So when we talk about the g function, so assume that you have a function g such that this output, this is output of this function output set. Suppose you have a function g from b to c somewhere, or let's say b to a even, or maybe b to c. So suppose you have a function. So not even here is B to C, not a different set. You have to take for the, we are talking about the inverse. So you have to assume that you have a function from set B to set A. Now, if you talk about the composition of here is going to be G of B. So G of B, sorry, G circle F. And this is this case is happening. You are getting the identity function. In that case, your G function is going to be, you will call not even this one, this should also happen. This is if and only if and here. F circle G should also happen. Yeah, F circle G will also be here. So this is identity in both cases. And even in the whatever we are studying, even this is follow or even single one is follow, you will say the inverse of it. This should both will happen when you will know the growth theory. There is one, or even you know the word, for simplicity for the time being, for this time you can think left inverse function, right inverse function. But here is no definition, sir have given left inverse, right inverse. So just the word here inverse. So if it is only this one is happening, that's fine. It is the inverse of the function. Okay. So there is no, for this course, there is no concept of left inverse, right inverse. So you will know more about when you study group theory or in BSc part. So, but for this course, there is nothing. Yeah, even the maths 2 also don't have left inverse, right inverse, only the inverse what is there. So if it is one, this thing is happening, then you will say, okay, inverse G is inverse of F, or F is inverse of G. For example, you can let's say f of x is equal to 2x plus 5. Okay, and we want to find a function such that when it take the composition, we want to find a function. This function is from R to R. So let's find a function G from R to R such that F circle G is identity map. Exactly whatever the input you will get when you take the composition, even the same value you will get. That's the meaning of, mean to say, the inverse. When you take the operation of two function, you are getting the same value. Exactly input value. In that case, your different inputs like sorry, the different of this one operands you can say.
Excuse me.
Yeah.
Sir, can you give an example of this function?
So let's find that now. How we will find now?
Okay.
So that's why we are going to find. So we have this function. We are trying to find this. We will try to find. It will not come random. You have to something. You have to do some with manipulation. Something you have to. Then you are able to find the inverse. So what you can do? You have this one. Fx is equal to 2x plus 5. So you assume this is, in the x-axis, y-axis, this is going to be the input, and this is going to be the fx, or you can say, already, fx as you used to be do with the y. You can think fx is equal to y. So for the simplicity, you can change fx as y. There is no mean to say that exactly you can work on the fx itself. So let's say this is y. For writing to be the step reduced to the writing the terms. Here is, then what you can do, this you can write as 2x equal to y minus 5. And this x is equal to y minus 5 by 2. Now just think that this y as, now you can think y as a variable x and fx as a dependent variable. Now mean to say Now your function gx should be what? X minus 5 by 2. X minus 5 by 2. Now, if you think about the composition of circle G, this is going to be this, and this would be 2gx plus 5, and 2gx is take this one, x minus 5 by 2 plus 5. This 2 cancel here. So x minus 5 plus 5. This is x. This is x here. So see that what we did. We did here. We have some function 2x plus 5. Okay. We did some manipulation, something we did here, and see, we got this relation. That means now it tells you something to find the inverse. So now you can think x as the function gx and y as a variable. X as a dependent variable and y as an independent variable. So from here you can infer something. Oh, something it's telling about gx. So gx is not this is a process, not exact process. This tells you the idea that how we will construct our gx. Actually we are constructing, it gives some idea how we'll construct, how our function gx will be. So anyhow, we got some idea from here, then you can tell, okay, gx would be like this. And once you found, you have to check, is this happening that when we are taking the composition, is to give the identity function or not?
Yeah, okay, sir.
So this is the process you can use at many places to find the inverse. Now, before we just talk about the inverse, how to find what is inverse, but didn't tell about the when we'll say a inverse function is exist. I just missed that part. So when we talk about the inverse will exist, can we talk about a function fx is equal to x square we have? Can we talk about the inverse of this function? It's difficult. The reason is, as here, for x is equal to 2, you will get 4. X is equal to minus 2, you will get 4. So when we are reverting, means we are getting a function. So here what we are doing, where input become output, output become input for the inverse function. So same here, the input is 2, output is 4. Input is different, but output is the same 4. So in this case, it is difficult to find the exact revert part. And then from here, it is difficult to find the inverse of this function. So that's why we need to put here some condition. When we easily find, or when we'll find the exact inverse of a function, so there is one condition you can put here, that when inverse is exist when the function is 1 1. So that function should be 1 1. In that case, you are able to revert that function. That means you can say that, okay, inverse can be exist for this function. Okay, without saying to be 1 1, you can compare with the case, because we are getting same output for different input, but we want the case for different output, for input, for a unique output, the input should be also the unique, not only two different input. The output also, input should be also different for different output. So that means to say a function should be 1 1. In that case, you are able to find the inverse. And actually, from here, the log function came. As you know, the exponential is increasing function. So increasing function is 1 1. So can we talk about the inverse of this function? So actually, yeah, it is 1 1. Then we can talk about. So what is inverse in that case going to be? So we have to construct that. How we'll get that? Let's say this function, and we know that, okay, this is 1 1. So we want to find a function g which give the identity. So how we'll construct? So from here, how we'll get that? So that's why the another different kind of function came log, or with the different notation. Log, there is log word. So log is nothing but the inverse inverse of the exponential. That's why the notation is also different. That's why the term comes log. How will get that x exactly? Now, if you take the composition x assuming to be with the base a, so actually each property of log is actually constructed while looking the exponential. How we will construct? Because we know that the exponential is 1 so surely inverse will exist. So how we will construct? So while looking this one, each property of the exponential we constructed, or means we have to construct that inverse. So it is constructed like this. That's why the log is actually the constructed, not exactly came or from where. Actually it is constructed while looking this exponential. Okay, we have to take something base, as here is we talk about that this is base and this is power. So here is thinking about the base and this is the argument will come here. We have to construct something so that when we take the composition, it give the identity. That's why the log term came. So log is actually came from not only the simply, it is come from the composition and talking about the inverse and then move on to the log. I don't know how much I talked. Is it clear to all of you or not? Is it clear to all of you?
Yes,
Right.
yes. It's clear.
So this is all about in week 5. Please let me know if anyone have doubt, or either now this is roughly reached to the 10 o'clock. We can end the session, or please let me know if anyone have doubt. Then we'll discuss and we'll end the session.
Natural exponential activity question.
No one have doubt? Okay. So is it clear to all of you, no? That what we discuss, how to construct, or what do you mean by the log, why the log came? The next week we'll see the log thing. So actually log is not came directly, it is constructed while looking to the exponential. And why we look the exponential? Because it is 1 1. Because of the 1 1, this mathematical whatever the person constructed the log because of the 1 1 of the exponential property of the 1 1 of the exponential function.
So we are not going to learn onto in this, right?
No. But hidden part is there. We are actually learning. See, onto is hidden here. Onto is here hidden. Can you tell me how it is hidden? Why how I said hidden? Hidden in the 1 1 itself. In the composition itself, it is hidden.
So because for G we take the range, and the range is the codomain.
Yes.
The codomain are same.
Yes, yes. Actually, here is onto is hidden for the function G. G is actually should be onto. Then you talk about when you take the composition, it is on you're talking output. That's why I said output in place of onto. So actually, output is hidden in the composition, but we don't. But here is not x. That is indirectly said here in the onto talk, but here is onto is hidden. Okay.
Yes, sir.
Okay. Okay, that's all about, I think. I just cover week 5. I hope is it clear to all of you. We have discussed. I don't know how it is, but I hope it's something makes clear to some composition, inverse function, log. That's all about from my side. Thank you so much. If anyone have doubt, please let me know. Otherwise, I'm going to close the session.
Sir, is there no any solve with us session for week 5?
So, for week 5, we don't think there should be a solve with us, but it could be. We are thinking it will be taken by some TA, because we used to be discuss the solution and giving the question. So probably it will happen on Thursday. I don't know. I just talked to the operational team to conduct the solve with us by a TA, but we didn't get response. If it is there, then you will get an announcement and will get a link in calendar. Possibly you will get. Tomorrow I have to connect again with the operational team. Anyhow, and it will be. It is possibly there will be a solve with us, but it will be taken by a TA. I will be there, but the presentation will be given by a TA.
Okay, sir.
Thank you so much.
Excellent, sir.
Yeah.
Sir, I saw in the calendar there are almost for many days. I saw in calendar there is written office hours.
Yeah.
Mostly for 1 hour.
Yeah.
Sir, what is the use of office hours? Can we ask some concepts over there or doubts?
Yeah, you can ask there. You can ask there. If it is not clear to you, they will explain everything. So you can ask the concept there itself. The most probably there is a doubt session. If you have conceptual problem, you can ask to hear in the live session. Instructor will explain more precisely. Either you can, the TS will also can explain that. So that office hour is actually given for the doubt clearing, and you can sit there and study with your colleagues, with your classmates or students, other students. That's the mean. Now actually that one of the office hour on in a day may be going to change in the challenging session. At least you will in a one session you'll get 2 questions at least. So in a week there should be possibly a day will remove and could be changed in the challenging session, which will be taken by TA. I thought already it would be happen with after the quiz. So possibly in the next week or in the upcoming week, sorry, in upcoming days or in next week, we'll get a session as a challenging session. Everything will get in announcement.
Okay, fine, sir. Fine, sir.
Yeah. Okay.
Sir, you will be also
Thank you,
available
sir.
in the office hour?
No, office hour only TA there.
Okay.
Thank you so
Okay, thank
much. This is all about this. Good night to all of you.
Good night, sir.
Thank you, sir. Thank you, sir.